Okay, so now what we're going to do is we're going to talk about the independence and the multiplication rule. So just to recap the lecture before, we were talking about, the question was the probability of E or F happening, one or the other. And what you did is you decided whether it was mutually exclusive or not. If they were mutually exclusive, it was just the probability of one plus the probability of the other. If it was not mutually exclusive, then you took the probability of one plus the probability of the other minus the probability of them both happening at the same time, right? The probability of getting a red card and a king, and then you have to subtract the probability of a red card and a king, okay? But now, in this lecture, the question is going to be the probability of E and F happening. So it's a little bit different. You're going to apply a different rule. Okay, let's say that, okay, the first question you have to ask yourself, kind of like you did before, you asked yourself if it was mutually exclusive or non-mutually exclusive. When you're talking about the probability of one thing happening and another thing happening, you have to ask yourself, are the events independent or dependent of each other? If they're independent of each other, that means the probability of the first thing happening has no effect on the probability of the second thing happening. For example, flipping a coin. Let's say I'm going to flip a coin 2 times, and I want the probability of getting heads and heads. So getting 2 heads in a row. So I flip the first coin. That first flip has no effect on the second one, okay? Kind of like Russian roulette. The first spin has no effect on the second spin, okay? They're completely independent of each other. Now, dependent events, the probability of one event does affect the probability of the other, okay? So the first event affects the probability of the other. For example, let's say I have a deck of cards, and I want the probability of choosing 2 queens, okay? So I put out the cards, face down, and I say, Rachel, pick a card. And she picks a queen. And then I give the cards so she keeps her queen in her hand. And then I give the cards to Joe. And I say, hey, Joe, now you're going to pick, I want you to pick a queen. Wouldn't the fact that Rachel has a queen in her hand affect the probability of Joe getting a queen? Because now there's less queens in the deck. That's just like if I were to give out a bag of candy. If I had a bag of candy to my class, and in that bag of candy I had all of this non-chocolate candy, and I only had 5 pieces of chocolate in this bag. And I were to start at the first student, and the first student picked out a piece of chocolate. Wouldn't that affect the probability of the last student getting chocolate? Sorry, I was talking and it just paused. I don't know how much you heard. I was going on a little rampage. No, but so the whole point is that if the probability of one event affects the probability of the other, then it's a dependent event. Okay? Once you've classified the events, then you just implement the formula. So if you know they're independent of each other, the events are independent of each other, and you're looking for the probability of E and F happening, then you just take the probability of E and multiply it by the probability of F. If it's a dependent event, then you take the probability of E and then you multiply it by the probability of F, given that the probability of E has already taken place. Okay, so I'll show you some examples to show you what I mean. Okay, let's look at this problem. Excuse me. About 6% of the population is math phobic. Now, most of y'all are probably like, it's way more than 6%, Mrs. Healy. But just for the argument of this problem, about 6% of the population is math phobic. If 2 people are randomly selected, what's the probability that both of them are math phobic? So the first question you have to ask yourself is are they independent or are they dependent on each other? Because I want the probability that one person and the other person are math phobic. So if you think about it, the fact that I'm math phobic has nothing to do with anybody else. Does that make sense? The chances me being math phobic doesn't affect the probability of someone else being math phobic. So these are independent of each other. So if the probability of one person is 0.06 and the probability of another person is 0.06, then the probability of one person and the other person, F, equals 0.06 times 0.06, which would equal 0.0036. And that's your answer. Okay, so it'd be 0.0036. So just keeping this in mind, what if I asked you, let's clear it, what's the probability that at least one person is math phobic? What is the probability that at least one person is math phobic? Now I want to talk to you a little bit about this, okay? Since the events that only one or both people are math phobic is mutually exclusive, like they're disjoint, they have nothing to do with each other, you can use the addition rule, okay, for at least one person. So it's because basically you can change this to the probability of one or both people being math phobic. You could do that, okay? But it's very hard to do it this way. I mean, like, if you understand it this way, that's fine. But it could just be really time consuming, because if you're saying, what's the probability that more than 5 people, okay, more than 5 people out of 20 like chocolate, more than 5, you would have to find the probability of the 6th person, 7, 8, 9, 10, 11, all the way to 20. It gets really time consuming. Or you can use the complement rule, okay? Wouldn't the probability of at least one person being math phobic be the same thing as 1 minus the probability that neither of them are math phobic? Okay, now think about that. What's the complement of at least one person being math phobic? The complement of at least one person being math phobic is no one being math phobic. Okay? But I'm not looking for the probability of no one being math phobic. I want this one. But we learned about complements. If you find the complement of one of them, you can subtract it from one and get your answer to the question being asked. Okay? Well, we already know the probability of not being math phobic because we know the probability of being math phobic is 0.06, right? So we would just do 1 minus 0.06 and we would get 0.94. And that's it. The probability of, so now what you do, so watch this. I need some space. I have 1 minus one person not being math phobic is 0.94. Okay, times another person not being math phobic is 0.94. So if you do 1 minus 0.94 times 0.94, you get 0.1164. This is the probability that at least one person is math phobic. And all I did was take 1 minus the probability of someone not being math phobic times the probability of someone not being math phobic, neither being math phobic. Okay? Hopefully that makes more sense. These are the more complicated. When you get to at least one, or at most, or less than this many, you just want to see what's the easier route of trying to find that probability. Okay, let's read through this problem, and then I want you to go ahead and pause it so you can make sure you have it down in your notes, and then I'm going to erase this and we'll try to work it out. Among 27 to 32-year-olds, 39% say they have called a talk show while under the influence of alcohol. Suppose 7 27 to 32-year-olds are selected at random. Okay? What's the probability that at least one of them has not called a talk show while under the influence of alcohol? And then I want to know what's the probability at least one of them has called a talk show while under the influence of alcohol. Okay, so I really wanted to focus on these ones where they have that at least in there because these are the ones that are pretty much the most confusing. So I'm going to erase this, so make sure you have this in your notes, and then I will try to break it down step by step, okay? Okay, so when I do this, at least one has not given a speech. So this is what you could do. Okay, this is where I want to try to break it down. I wanted to show you how it could be complicated, or you could think about it a whole different way. But this is something you could do. That at least one of them was not under the influence. So that's the probability that one was not under the influence, and then all of the rest of them were. Okay? And then, so that's one that's not. Let me kind of clear this. I'm trying to do it one way. Let me do it like this. Possibility 1. That one of them is not under the influence. Now, this is that they have been. So, what's the complement of that? 1 minus 0.39 is 0.61. 0.61, that's the person who's not, okay? Then you have everyone else who has, and that's 6 more people, because we said 7 were. So, the 7 people were selected. So I have 0.39 6 more times. Okay, but that's only one way. At least one, that means 2 of them could have called that were not under the influence. And then that means 5 more people were. And you would have to do this for every scenario. That's way too much. And then you would have to add all of those probabilities together. Or you can ask yourself, what's the complement of at least one not being under the influence? That they all were. Okay, that they all were under the influence. So then you could just take 1 minus the probability of all of them being under the influence. Okay, so that means that I would have let me erase that. I would have 0.39 7 times. But couldn't I just do that in an easy mathy way and just do 0.39 to the 7th power? Because it's 0.39 times 0.39 times 0.39. So it's 0.39 7 times. And then that's an easy little thing that I can put in my calculator. Oops, I put a minus instead of, negative instead of 0.39 to the 7th power. Okay? And I get 0.9986. And that's my answer. Okay? So the probability that at least one person has not called a talk show while under the influence of alcohol is 0.9986. Okay? So now let's look at part B. Okay? At least one of them, one of the 7 that we chose, one of the 7 that we chose would be under the influence. What's the probability of that happening? Well, think of the complement. What's the complement of at least one was under the influence? Then none of them are under the influence. And we know that the data that they gave us, that the probability of a caller calling in being under the influence is 0.39. That means the probability of the caller calling in that's not under the influence is 0.61. So if I want the probability of at least one person under the influence, I would do 1 minus the probability of no one being under the influence, none of my 7. So I would have 1 minus 0.61 to the 7th power, because I'm going to say none of my people are going to be under the influence. And if you do that, 1 minus 0.61 to the 7th power, I get 0.9686. And that's it. That's your answer. That is the probability that at least one person will be under the influence out of the 7 that I've chosen. Okay, so hopefully that makes sense. You grasp it a little more. Just try your homework and look at a few more examples, and let me know if you have any questions.